The reason I'm interested in making wheels and pinions in the first place is I want to be able to make everything that's in a watch. But in particular, I bought this Verge Fusi movement, just the movement, for $30 or something. And it was missing the hour and minute wheels, which go on the front here. And the cannon pinion is kind of in bad shape. So the first thing I want to try to do, because this is a pocket watch and it's larger, and these wheels and pinions are hard to replace, I want to, test my skills to try to make the wheels and pinions to get this working again. So because the verge of escapement is a little bit harder to see and it differs from modern movements, first I'll just give you a review of how modern movement works. The barrel is underneath this wheel, and the barrels, there's a wheel on the bottom of the barrel which is where the energy escapes from the mainspring. And that wheel is considered or called the first wheel of the gear train. And then you have the center wheel. So the wheel on the bottom of the barrel drives directly the pinion on the center wheel. Here you can see the wheel, the first wheel on the bottom of the barrel, and how it interacts with the pinion on the center wheel. And the center wheel is the second wheel. In this case, it's also the center wheel. The center wheel doesn't have to be in the center, but in a standard movement it is. Here you can see the pallet fork interact with the escape wheel. And you can also see the back part of it interacting with the impulse jewel on the bottom of the balance wheel. So this is the part that goes back and has the little fork on it that interacts with the impulse jewel on the balance wheel, which is rotating back and forth. And then on the front, you have the pallet stones that are interacting with the escape wheel. So this is the second wheel or the center wheel. And then you have the third, fourth, and escape wheels and the balance wheel. Now on this side of the movement, we have the shaft for the center wheel coming up to the cannon pinion here. And then the cannon pinion has teeth on it that engage with the Minihand wheel. And this is part of the system that divides that down to the hour hand wheel. So the relationship between these pinions and wheels is that one of them has a gear ratio of 3 and the other has 4. So when you combine them, they have a gear ratio of 12. So the Minihand, which is this center shaft, is moving once per hour, and then that's being divided down by 12 to drive the hour hand. So the hour hand attaches to the outside of the top of this gear. And the Minihand attaches above that to this top of that. So here you can see that a little bit better. The cannon pinion and the hour hand wheel. So for this project, we have to remake the hour hand wheel, the Minihand wheel, and the pinion attached to that, and the cannon pinion. And all we have is the broken cannon pinion as a starting point, but we also have on the verge, there's a hole in the main plate that serves as the anchor point for the rotation of the Minihand wheel. So on this movement, you don't need to worry about this, but this has to do with winding and setting. So this whole piece pivots, and when you pull the stem out, it pivots in, and the stem will drive this Minihand wheel to set the time. And it should overpower the cannon pinion when you're powering that through the gear train. Through this little gear train. And it should change the hours by rotating this pinion. You can see that center shaft is not moving when I do this. The outside of the cannon pinion is turning though, and the outside of the cannon pinion is what the Minihand is attached to. So the minute hand would turn, but the driving shaft powered from below does not turn. So that's a special friction relationship between the drivetrain and then the setting wheels. So the minute hand is attached directly to this outer sleeve, and you can see when I set it, when I force this gear, which the setting gears would do, the outside of that turns. And you can also see the gear ratio there of the minutes being divided down to hours. This is the bottom of the mainspring barrel, and this is when you're winding it. This turns this, which turns the arbor in the middle of the mainspring and tightens the mainspring. And then that wheel you saw on top of the barrel, the steel wheel with the click, that is also attached to the arbor in the barrel, and the click is on the other side. That keeps the mainspring wound and keeps the power from escaping directly. So even when you disengage the winding, the power doesn't flow out because of the click. So the mainspring is delivering energy to the pinion on the center wheel. The center wheel directly drives the minute hand on the other side of the movement. And then the minute hand has a cannon pinion, which is a little pinion that is attached to it that drives through a division of 12, the hour hand wheel. And that's on the other side of the movement. That's what we're going to remake for this Verge watch. But just to explain how the power flows, the purpose of the gear train after the center wheel is simply to slow down the power escaping from the mainspring. So the power escapes directly from the mainspring to the center wheel, to the minute hand, and then the third, fourth, and escape wheels each gear it down. You can see the escape wheel moving faster. The fourth wheel is moving at the rate of a second hand, which oftentimes it's used as the second hand. The pivot for this can point through the front of the watch and become a small seconds hand. And then the third wheel, you can see it moving very slowly. And then the minute hand is moving almost imperceptibly slowly, but you can also see that move, the center wheel. So this is all just regulating the power flow out of the mainspring and making it so the watch tells time. And the Verge has the same gears, but they're inside and they're a little bit harder to see. So I just thought it'd be good to go through this before I go through the Verge. So this is an example of a modern ETA movement, a 2789, in which the train of wheels is kind of in the reverse order. So the seconds hand is the fourth wheel is the last one, but that's at the center of the movement because it's center seconds. And then the third wheel is here, and the second wheel, which would be the minute wheel, is here. And then on the other side of the movement, there's a gear to bring the minutes to the minute wheel sleeve around the center seconds. But if I move this a little bit, you can see the gear ratios are different. So the fourth wheel is moving the fastest, the second hand at the center. So now that you've seen how a standard modern movement works, you can see how the standard movement evolved from the Verge Fusee. So the project here is to rebuild these two gears and pinions. The cannon pinion exists, it's here, but it's missing some teeth. So they'll have to be recreated, and then the minute wheel and the hour wheel will have to be totally created, and the minute wheel has a pinion inside of it, they'll have to be created. And the way that the Verge works is the mainspring is inside of a geared it's not geared actually, it just has an anchor point for this chain. Anchor point's right there. So the mainspring is inside that barrel, and then there's a chain wrapped around it, and the chain is pulled by this wheel, which is the first wheel, which is also called the fusee, which would be equivalent to the wheel on the barrel of a modern watch. So you have the first wheel, and then you have the fusee acting as the barrel, and then you have an actual barrel pulling on it. And the reason that this is graduated in these different in the spiral is because the torque changes as the mainspring expands. So the idea behind that was it makes it more accurate, because these watches weren't very accurate. It helped accuracy by keeping the torque on the train of wheels more equivalent over a period of the spring unwinding than it would otherwise be. And then, so as the fusee is the first wheel, the center wheel is the second wheel, just like in the watch movement I just showed you. And that's also the minute hand. So that's the center wheel, second wheel. You can see the pinion on it down in there. And then you can see the outside of the wheel contacts interfaces with this pinion. So this is the third wheel. And then the third wheel interfaces with this pinion on the fourth wheel. And then this is the fourth wheel with the vertical teeth. And then the escape wheel is back inside, mounted horizontally here, and the fourth wheel is interacting with the pinion of that, and then that's your escape wheel. And on the left here you have a mount point for the axis of the escape wheel that looks like it's somewhat adjustable, and then you have this element which is holding the other end of the pivot for the escape wheel. And then instead of having a pallet fork, it just has these little tabs on the center of the balance. So this is off axis. Basically the balance axis is not the center of the watch. It's just lined up here. That may be obvious, but the center, this little point is the pivot for the second wheel, or the center wheel, and the center of the balance is here. Just when we look in it like this, they look like they're the same thing, but they're not. This is the minute hand center wheel column, and then in the middle of the watch, but off to the closer to camera, is the axis for the escape wheel. So it has these little tabs that flip back and forth and allow the alternating escapement to switch back and forth with the rotation of balance, just like in a modern design, but different. And that's basically it. Underneath this is a gear. This square pivot point is geared around at the bottom of that, and that gear runs on a rack which is under here. You can see just the end of the rack poking through right here, and that rack has a contact point with the hairspring, so you can effectively change the length of the hairspring. The hairspring is anchored here on the faceplate, but that rack is connected to a stud that holds the hairspring, and you can effectively change the length of the hairspring to regulate the watch. And normally it's missing from this movement, but there would be an indicator on here, which is just a disc with a square hole in it, so it moves when you rotate the gear using a key, and it would have a pointer on it, and that would help you remember where it was pointed, or make note if you're going faster or slower. A and R is advance and retard. I just touched the fourth wheel, that's why it stopped. And then the other thing is, when you first assemble the watch, or if you've been working on it, you have to introduce power into the mainspring, because when you first put it together, it's going to be slack. So this click, it has no spring. It's just held in place by spring tension in the barrel. This is the arbor. And when you first assemble it, you have to let this click out of the way, or in any case, you have to rotate this to bring to wind the mainspring, and then drop this click in, and then it just stays there permanently. And then after that point, the escapement itself acts as the click. Like the power can't get out because the escapement is always engaged. And when you wind it, you simply turn the key above the fusee. So you bring the chain all the way onto the fusee, and off of the barrel, and then the barrel pulls it back. And then to wind it again, you pull it back to fusee, and the barrel pulls it back. So there's no click per se. And this could be confusing because normally a click has a click spring, but because this is only used when you're first setting up the watch, there's no need for a spring. You do have to kind of manage it when you're setting it up, because if you need that spring action, you kind of have to loosen the screw, let gravity pull it down, and then turn this gear until you've got the proper tension on the fusee side, or on the mainspring side. Oh, and then finally, this spring is just for casing. It hinges, these movements hinge in and out of a case like this. And then when it drops into the case, this is the dial side of the movement. So when it drops into the case, this latch, spring and latch would hold it in the case so it doesn't flop out unless you want it to come out. And then when this eventually has the gears replaced and a dial on it, this will be the 12 o'clock position, and there'll be a hole in the dial for winding it, and then setting will be done by turning the cannon pinion, basically, which will be on here. This movement is marked Breguet number 1560 à Paris, which means at Paris. And it's not a Breguet in the sense that it's not a special watch. It could be either a counterfeit that somebody just put Breguet on, or it could be the Breguet marked standard movements. There's some evidence in George Daniels' book about Breguet that Breguet, commercially, they use standard movements in watches that were sold to the public. There's the high horology side of Breguet, and then there was a more commercial side. So this could actually be a Breguet, but it's not like a handmade by Breguet himself. And then there's one other thing. These pins hold the whole thing together, which is interesting. Instead of screws, at the top of each of these pedestals, you push a brass pin through it to hold the whole thing together. On some fusees, there's a jewel underneath this cap, and on this one, I think it's not. There's just the bearing is underneath there, the pivot in a brass bearing, or just in the brass plate. Okay, so that was the introduction. This is the movement that I showed you at the beginning of that. I bought this for like $1.50, $1.50 at the Salvation Army thrift store, and I love it. It came without a case, so eventually I'll have to try to find a case for it. But there's something really interesting about this movement, which is this wheel is purely cosmetic. It does absolutely nothing. And I'll show you that right now, just so you don't think I'm crazy. It's a reverse threaded screw. And look at that. There's nothing going on under there. So if you have any doubt about that, all the movement databases also state that's a unique thing about this movement. Now, normally what that ratchet wheel would be all about, I think that's what it's called, is the stem would go in here and drive that from below. So it's possible that there was a different, this movement was made with, there's no explanation for it really that I can think of. If anybody has any idea, let me know. The thing I was going to say is that this plate, bridge plate or whatever, it's not really a bridge plate, but this plate could have, you know, the base movement could have been designed so it could be manufactured different ways, but it still doesn't, there's still no reason to put that there. And then, even more amazingly, this movement, which is a I can't read it, 213 or 273. Let me see if I can read it like this. 273. I forget the manufacturer, but the it's not the same company, although they might have the same parent company. Check out the ratchet wheel on this. You ready for this? Same freaking thing. Does nothing. And both of these watches were, this one I got from, a couple years ago I bought a lot of vintage parts. I made a video about it. This was just one of the miscellaneous things in that reverse threading. Okay. I cannot see what I'm doing without a loop or the microscope. Oh. Well, now I've got the microscope, I should show you again. See that? Nothing. Again, it should be geared to a winding gear here, but this movement also has the that whole system is on the other side of the movement. So what I was going to say is that it amazes me that they bothered to populate this. You know, it's one thing to make the plate in such a way that it could accommodate. Oh wait, that's not reverse threaded. It's one thing to make it so it can accommodate a wheel, but then why put the wheel there? And also, I want to point something out just for fun. This is what's called a cylinder escapement, and this escape wheel has teeth that basically on the balance, which is missing from this. There's a cylinder that has a hole, like a gap in it, and the cylinder works like a impulse jewel in terms of it turns and opens and closes to let the escape wheel turn. Since this doesn't have a balance, you can also see a nice demonstration of what happens with it when a watch has no balance. The energy just flows out of the mainspring. And on the other side, you get this action. So anyway, I hope you enjoyed that. Let me know if you know why they would populate those gears, why they would design it that way for gears that do nothing, and then why they would populate them with gears. I think it's just marketing, but it's also funny because it's like the end user of the watch doesn't know it's there. So, all right, thanks for watching.